Okay, so as requested, I'm recording the answers to the calorimetry problems for their worksheet. So the first one that I was asked about was the coffee cup calorimeter with the 100 grams of water and the hydrochloric acid being mixed. So I've given the grams of the water and the volume of the hydrochloric acid. I'm then told that the hydrochloric acid had an initial temperature of 44 degrees Celsius and the water was originally at 24 degrees Celsius. And I'm told that at the end of the reaction, the temperature for both of the substances is 31.3 degrees. The first question was the reaction endothermic or exothermic. Is actually both answers are correct because it depends whether I'm considering it from the perspective of the water or the hydrochloric acid. So let's look at it from the water first. So the water started at a temperature of, what was it, 24.6 degrees Celsius. And its temperature went from 24.6 degrees and it increased to 31.3 degrees Celsius. So since the heat of the water increased, or the enthalpy of the water, right, because we say heat is equal to enthalpy, this is an endothermic reaction because I need to add heat, right? So water increases in temperature, therefore the Q has gone up. From the perspective of the hydrochloric acid, though, right, the hydrochloric acid starts out at 44 degrees Celsius, so 44.6 degrees Celsius, and at the end, it's gone down to 31.3 degrees Celsius, so it has lost heat. So from the perspective of the hydrochloric acid, this is an exothermic reaction. So either answer would have been correct as long as your justification, depending on whether or not your justification was from the perspective of the water or from the perspective of the hydrochloric acid. So if you're considering the water to be the system, then it's an endothermic reaction because it actually gained heat. And if you're considering the hydrochloric acid to be the system, it's an exothermic reaction because the hydrochloric acid actually lost heat. Okay, so this one was a little bit subjective. Oops, made a squiggle. The next question in this one was a little bit more direct. It said to calculate the heat of the reaction from the water. So oops. Remind me tomorrow. Sorry, something with my computer. So it asked you to find the delta H of the reaction for the water. So I'm sorry. Oh, I didn't copy the second question. I think it's to find the heat, the Q, right? Give me 1 second to double check. Hold on, pause the video. Alright, sorry, the second part said to calculate the amount of heat that the water lost or gained. So we know from the first part that the water, what was it? The water gained heat. So I should have a positive heat. So for this, I'm just going to use my Q equals MC delta T. So Q equals MC delta T, where the M is the mass of the water, so 100.0 grams. C is the specific heat of water, so 4.18 joules per gram degrees Celsius, and the delta H is going to be the change in temperature of the water. So the change in temperature of the water is from 24.1, so 31.3 minus 24.6. And when I plug this all into my calculator, let me get a calculator first. Alright, so when I put this into my calculator, I got 2800.6, which in this case would be joules. Let's check our sig figs. So we have 4 sig figs, 3, 3, 3. So I'm going to round it to 3 sig figs, which I can't do in normal notation, so I'd have to do 2.80 times 10 to the 1, 2, 3. So times 10 to the 3 joules would be rounded to the correct number of significant figures.